you ever found managing complex cloud-based data pipelines intimidating or overwhelming? Discovering the right techniques to simplify this can make a world of difference. Stay tuned to find out how. In previous videos, we outlined the revolutionizing benefits of modern extract load transform (ELT) processes and DataOps foundations. In this video, we'll further explore these modern practices for data operations and analytics engineering. Specifically, we'll focus on in-warehouse transformations, the T in our ELT pipelines. You don't need to watch the previous videos to follow along, but we'll link to them, as well as all our code and data, in the description of the video. For background on the setup, our data originates from YouTube Analytics pulled through an extract load pipeline via BigQuery Data Transfer. Other extract load tooling can be used here, like the popular Fivetran. Our raw data, transformed data, and transformation jobs called BigQuery Home. We draft out these transformations using Dataform, a BigQuery native service. If dbt is your go-to tool, don't worry, these principles still apply. In our Data Explorer, the raw data's final destination is a specific YouTube dataset, created, updated, and named via our extract load pipelines. From there, we create derived views and tables. But how do we architect these transformations? Beginners often rely on standard BigQuery queries. These can be scheduled or perhaps orchestrated with Cloud Composer, a managed Apache Airflow service. However, when these systems scale, the complexity becomes untenable, pipelines become brittle, and agility plummets. A switch to a structured analytics engineering method could be your ticket to simplicity. In Dataform, we house a variety of source declarations, a reference point, and foundation for our data transformations. A bit downstream, we see some staging transformations, making small alterations and simply tidying up the raw data. Did you spot the folder for our data mart transformations with elements like facts and dimensions? These SQLX files are also modular transformations that curate, enrich, and clean up our data. Regardless of your exact data modeling approach, modularity should be your mantra. Our expedition through the compiled graph revealing the lineage and structure of this data platform shows us the network of modular transformations between our source data and the final tables. The goal? To simplify each one of these boxes, each transformation, to a degree where it speaks for itself. Large, complex SQL scripts for data transformation that baffle everyone are a no-go here. In this case, we've opted for a staging layer, followed by some downstream facts and dimensions. Our trusty SQLX scripts within Dataform power all these transformations. Keeping things simple, our foundational staging transformation is just a select query, steering clear of any DDL in our transformation. This leaves the heavy lifting and DDL boilerplate to the platform. Good news for those who love documentation, we've got it for scripts, tables, and even specific columns within transformation definitions. Various data tools have differing approaches, but Dataform and dbt alike use select statements and avoid DDL commands, which greatly facilitates simple, clean transformations. Of course, this implies that we need to separately define the derived asset type, like distinguishing between a table and a view. That's simply handled in the config at the top of the transformations. We've also meticulously organized things into different folders. We have a source and staging directory, as well as higher-level transformations in our data marts directory. These data marts have more advanced transformations to curate the data. For instance, we can have joins of a couple of our staging tables. Optionally, we can use SQL or JavaScript functions in these transformations to better reuse code and keep things modular. Once we've defined these transformations for our data, the next step is execution. Hopefully, you've noticed that we're extensively utilizing references in our SQL scripts. This is intentional. We want our system to understand the lineage and dependencies of our data assets. Hence, when executing our transformations, we can optionally include transformation dependencies or dependents with the single click of a button. Using this paradigm, we don't need to run every single data transformation job when we have an updated data source. We just use the dependency features and run only the impacted downstream transformations. Of course, we can always run all actions in the workspace. Even then, all the transformations will run in the order that they need to, respecting any dependencies inferred from the references in our SQL script. If we initiate the execution and switch to the Executions tab, we can see this principle in action and a staged execution of our transformations. Most use cases will require automated scheduled workflows. Thankfully, with tools like Dataform or dbt, we can accomplish this by using Git-based methods for releasing on specific frequencies. These releases contain multiple workflow configurations that allow us to update the required assets in our data platform. The Git feature integrates with providers like GitHub or GitLab. You don't need to know Git commands to leverage this GitOps-based system. For instance, as changes are made to our files, you'll be notified of the alterations and can conveniently commit these changes in a no-code fashion. At the end of the day, our GitHub-powered, cleanly managed, and orchestrated transformations result in curated, business-contextualized data assets that our analysts and business users can effortlessly utilize. The underlying machinery that powers all this is designed to be transparent and easy to manage. We hope this video has been insightful and look forward to having you join us in the next video of this series. Thank you very much for watching, and please enjoy responsibly.